right, some vocabulary for us, which actually we already saw in Module 1, some of this vocab. So just as a reminder, a quadratic function has a graph that is a parabola. And we saw that in Module 1 when we were talking about like the transformations, when we were talking about going to the right or to the left, flipping. We saw parabolas and absolute values. So these are the U-shaped ones. So in Algebra 1, there's a lot of stuff in Algebra 1, but Algebra 1 is really about linear equations. And in my mind, Algebra 2 is really about, okay, let's think about equations with other powers. And these quadratic functions are big ones, and they're the ones that have a second power. So it's something x squared. So this is the standard form of a quadratic function. Remember, we had standard form for linear equations too, and I thought that was a little stupid. Standard form for quadratic functions is like your biggest form. So what's going on here is we have f of x equals ax squared plus bx plus c. And we specify where a is not 0 just because otherwise it'd be a linear equation. So really, they call this a term. It's the number next to your x squared is the quadratic term. And then the number next to your x term is called your linear term. Don't worry about those vocab, but I will call this last number that doesn't have an x, that's your constant term. So I will refer it to as that. So these graphs have like parts to them. The first part is the y-intercept is c. So this number, this last number that doesn't have an x, that's going to be your y-intercept. And as a reminder, y-intercept is that thing that crosses the y-axis. So that's right here, y-intercept, and it will always be 0, c. The next vocabulary for us is the axis of symmetry. This thing right here. This is the line that cuts the parabola in half. So the axis of symmetry is right here. And so that we don't have to write axis of symmetry all the time, I will always abbreviate it as AOS, or often abbreviate it like that. It's the axis of symmetry, and it does have an equation for it. Its equation is x equals negative b over 2 times a, where b is from this general equation or standard form, and a is from the standard form. And it's x equals because, again, it's this vertical line. And how we're going to use that when we're graphing is that this like distance here between the axis of symmetry and this point is going to be the same distance from the axis of symmetry to the other side. So we're going to use our y-intercept to graph these. The last thing is the vertex. So the axis of symmetry intersects the parabola at its vertex. And I'm color coding here. I had a little marker that I did something with. You guys know I like color coding. So the vertex, its x coordinate is negative b over 2a. This next part is going to be confusing when I first write this, but then I think when we do it, it gets a little more clear. So this is your vertex, and it's an ordered pair. It's a point on the graph. So its x value is your axis of symmetry, which is this number negative b over 2a. And that'll just be like a number like 1 or 2. If I'm being mean, I'd give you a fraction, but I always give you a whole number. The y part is the weirder part. I'm going to use function notation here. So it's f of negative b over 2a. Remember, all that's saying is that you plug in this value. So if this was 2, you plug 2 into your original function and you'll get a number out. That's what this y is. Again, this looks kind of confusing. We will go through and do an example, and hopefully that'll clear that up what that means, or at least a little bit. Okay, this next part, maximum or minimum values of quadratic graphs. This is sort of obvious, but let's put some things in language too. So the vertex of a quadratic function is either a maximum or a minimum, meaning it's a minimum if it's on the bottom, maximum if it's on the top. The graph of y equals ax squared plus bx plus c, where a is not 0, opens up and has a minimum. So opens up and has a minimum when a is greater than 0, which is positive, and opens down and has a maximum when a is less than 0 or when a is negative. So the way I want you to think of that is basically if you have a positive ax squared plus bx plus c, positive people are happy, have a happy face. Versus if you have a function that's y equals negative ax squared plus bx plus c, whatever those numbers are, negative people are sad people. Okay? It's the easiest way to remember it. Why this matters is because we are back to talking about domain and range. Riley, the notes are up here if you want. So, domain. This is going to be an easy one for you guys. There is no value of x that you can plug in that breaks this, which means your domain is all real numbers or negative infinity to infinity. So, easy answer for any quizzes in this section. Domain is negative infinity to infinity. Your range, here's where things are different. So remember, your range is if you squish this parabola onto the y-axis. If you have the happy face, your range is going to start at your y minimum, and it's going to go up to positive infinity because we are positive, happy people. Your range for the sad face, you're going to start at negative infinity up to your y minimum. And that it'll always include the y minimum, that bracket part, because it's actually the vertex. It's part of your function. So we are back to talking about domain and range. Okay, hopefully you're with me so far. You probably have questions and you don't even know you have questions because this is easier to do than to just like give you the formulas. So let's do some examples here. We're going to look at some examples in standard form first. So this is example 1. Graph a quadratic function in standard form using axis of symmetry, vertex, and y-intercept. So I like to put the formulas on top just always so that I can help myself memorize them and also so they're right there. Negative b over 2a. That's my axis of symmetry, and it is x equals because it's a vertical line. My vertex is negative b over 2a, comma, f of negative b over 2a. And then my y-intercept is 0, comma, c. Okay, so in general, what you want to do first is label your a, b, and c. So part A here, we have f of x equals x squared plus 2x minus 3. What is my a term? What's the number in front of x squared? 1. What is the number in front of my x? What's my b? 2. And what is my constant term, my c? -3. Perfect. Everyone see where those numbers came from? Does this open up or does it open down? Why does it open up? Because it's positive. Because a is positive, right? If this first number is positive, positive people, we open up. We're a smiley face. All right, so the order you want to do these. You could do the y-intercept first if you wanted. I usually do axis of symmetry, vertex, y-intercept. You have to do the axis of symmetry before you do the vertex. So our axis of symmetry is going to be x equals negative. What is my b value? 2 over 2 times, what is my a value? 1. All right, 2 times 1 is 2. What's negative 2 divided by 2? -1. -1. Okay, that's my axis of symmetry. I'm going to take this axis of symmetry. Now that I have it, I'm going to go ahead and plot it. I put it as a dashed line, not because it's an inequality. You wouldn't be marked wrong if you put it as a solid line, but just because I want to differentiate it between my parabola. So that is my axis of symmetry. Now the vertex. So what that function, that funny notation really meant, you have your vertex. Remember, it's an ordered pair. We already have the x value is -1. That comes directly from the axis of symmetry. This next number comes from taking this function up here, f of, but now instead of x, let's do f of -1. And every time I see x here, I'm going to put a parenthesis -1. So I have -1 squared on the outside plus 2 times -1 minus 3. All right, you can talk yourself through this calculation. What is -1 squared? What's -1 times -1?
1.
Positive 1. What's 2 times -1?
-2.
And what's, well, then minus 3. So 1 minus 2 is -1. Minus 3 would be -4. So then my y value for my vertex is -4. That's all that function craziness meant. You plug this number into this and you'll get a number. Now, some things to note. First of all, you guys know I love calculators. They can do the legwork for you. But some things to be careful for. If you type in -1 squared with no parentheses here, the darn calculator tells you it's -1, and that is not true. We just said -1 times -1 is +1. So remember, the workaround for that is you have to have it in parentheses and then square it, and it'll tell you it's +1. So that's why I always plug these in parentheses anyways, because then you can actually just type this whole thing up. If you want to type in -1, close your parentheses, squared, plus 2 times -1, close your parentheses, minus 3. Look at that, it's -4. Okay, you just have to watch out for that. The negatives are probably going to be where you go wrong on your axis of symmetry and vertex. Okay, so I have my vertex here. I'm going to go ahead and plot it with this. I had a better blue marker. This one. It's broken. Okay. So I'm going to go ahead and plot this at x equals -1 down then 4. Okay, there is my vertex. The last part, the easiest part, is my y-intercept. Remember, your y-intercept is always 0, c. What's my c? -3. So you could, again, do that first if you wanted to. So that just means this point here is right there. All right, why it's important to have that y-intercept. Remember, this distance is the same on the other side. So you have another point that's 1 away from the axis of symmetry on the other side. You need 3 points to make a parabola. You need that bottom of the U. But once you have those 3 points, make sure it's curvy. These are not absolute values, so don't just connect them straight. It's not like a V, it is a U. And there's our parabola. Okay, so it's a process. This is like your step 1, 2, and 3. My domain is -infinity to infinity. My range, I'm going to start, since I'm happy, I'm going to start at my y minimum, which is -4. It comes from your vertex. Up to my happy face, I'm a positive person, I'm positive infinity. Do you have any questions so far? It is a process. This one you just have to do a couple times and get it into your brain. Let's do another one. So looking at part B here, notice I did not put this in function notation. I just wrote it as y equals. You can use either one. I prefer function notation, but I just want to remind you these are the same thing. So you have y equals -x squared plus 2x plus 1. What is my A term? -1. What is my B?
2.
And what is my C?
1.
Good. Do we open up or down?
Down.
Down, because now my A is negative. All right, let's start with the axis of symmetry. I have x equals. Now you have to be careful here. I put in the negative and then my B, just 2. If your B was -2, you have to put in 2 negatives. Negative, negative. Okay, you're going to see that on your homework. Always have this part and then plug in your B. So if you have a negative, negative, that's how you get a positive on the top. over 2 times my a, which is -1. 2 times -1 is -2. What's -2 divided by -2?
1.
+1. We knew it was positive. Okay, that is my axis of symmetry. I'm going to put a dotted line or dashed line or whatever here. Once I have my axis of symmetry, I'm going to find my vertex. So take this number, that goes here, 1, comma. All right, now we have to take this equation, but I'm going to plug in 1 instead of x. So I have y equals, and then it's going to be negative on the outside, and then a parenthesis, 1 squared plus 2 times 1 plus 1. The reason this matters and the reason it's different from this one is the -1 was on the inside here, so it was saying -1 times -1. This one's saying 1 times 1 times -1 on the outside. It's really sneaky. It's why your calculator does what it's doing. So just watch out for that. Like when you plug in the x, this will still be negative because it started as negative. So it's going to be -1 squared, and I just have the 1 in parentheses, plus 2 times 1 plus 1, and you end up with 2. So then this is 2, close my parentheses. Okay, so my vertex is going to be over 1 up 2. Should say to the right, 1 up 2. Do we have a question or anything? You're just marveling over that negative? Okay, last step, y-intercept. I don't know why I botched this whole thing. Y-intercept. It's 0, comma, what's my c? +1. So 0, comma 1. Really not sure why I botched the whole thing earlier. It's just this. So over 0, up 1. All right, and then my other point is going to be 1 away from my axis of symmetry on the other side. And then I just connect these with a curvy line. Again, not a V shape. Okay, so now we have our sad face. My domain is still -infinity to infinity because that just describes my possible x's. But my y, or my range, can anybody tell me what the range is? What do I start at? If I squish this down onto my y-axis, where am I starting? I agree it goes up to 2. But where do I start? Do I start at 2? Yeah, -infinity up to 2. So if you're downward facing, you start at -infinity. Good. Okay. It was a lot. Like I said, I feel like once you do these more, you get the routine in. It's sort of like practicing driving. Are there any questions about example 1? Okay, I'm going to do example 2. It's slightly easier. So example 2 is vertex form. So we talked about standard form, which is honestly the form that you most of the time see. But vertex form is another form that we have. So remember when we did like linear equations, we had slope, intercept, and you could see your slope and your y-intercept. We had point, slope, and you could see your point and your slope. Vertex form, you can see your vertex. So we don't have to do that whole calculation for the axis of symmetry of the vertex. So it's this y equals, I'm going to write it bigger, y equals a times x minus h squared plus k. And so the really nice part is your vertex is just h comma k. Now, one thing to note though, notice this is a minus. So what you're going to have to do is you're going to have to always like flip your sign on your h. Just on your h part. Because if it's a positive number, so like right here in this example, it's +3, that means your vertex is -3. comma, -2. So you don't have to change the sign here, but you do have to change the sign here because it's a minus -3. So that part's a little weird. The axis of symmetry is always just x equals h. So it's x equals this first number. The weirder part is your y-intercept. You're going to plug x equals 0 into your equation and solve for y. So that's like the hard part of these ones. And I put hard in quotations. I don't know why I didn't ask for an A here, but I should have. So what is your A part? So it's not listed here, but what number is in front?
1.
1. So do we open up or down? Up. Okay, so that still is true. Your A is still that first number. How about my H? What is my H? It's not the part on the inside the parentheses. It's what?
2.
Okay, it says +2, so what do I have to
4.
do? Not 4. Flip the sign, so I have to make it -2. Just flip your sign. And the reason, again, for that is because really what's happening here is this is x minus -2 squared minus 1. Like, that's the general form. So that's what's happening here. What is my k then?
-1.
-1. Okay, so here's the awesome part. Axis of symmetry is just x equals -2. No calculations required. Just going to go ahead and plot my axis of symmetry. My vertex, since this is in vertex form, you just take your h comma k, so it's -2 comma -1. So I'm going to go over to the left 2, down 1, and put a point. Okay, the harder part, my y-intercept. Okay, so just as a reminder with function notation, this g of x is the same thing as y. So in our definitions, when I said plug in x equals 0 and solve for y, plug in x equals 0 and solve for g of x or whatever. Like if you want to rewrite this as a y, that's fine. So I am going to rewrite it as a y. I'll do y equals, and then I take this equation, but instead of x, let's put in a 0. Plus 2 squared minus 1. What's 0 plus 2?
2.
Okay, so I have 2 squared minus 1. What's 2 squared?
2. 4.
4 minus 1, so I have equals 3. So my y-intercept is at y equals 3. Oops, sorry. Y equals 3, or as an ordered pair, 0 comma 3. Are we okay with how I found that? Really, you just kind of like cover up the x and solve for y. Okay, the last part. How many away from my axis of symmetry am I? 2. So then on the other side, I need to go 2 away, and I have a point here. My domain would be -infinity to infinity. And my range, I'm a happy face. So then where do I start? -1, and number always gets a bracket, up to what? Positive infinity, because we are positive. That's it. Vertex form, a little easier, I would say. Do we have any questions about vertex form? Do we have questions in general? Okay, I will be sure to move around while you guys are working on these. So